Good evening, folks. Hope you can all hear me. Don't know if this is going to be coming through. It's been a while since we've done a live stream. Unfortunately, my camera and streaming software today decided they needed several updates in order to work properly. So I'm hoping that this is all, visible to you guys. Trying to just see here, it doesn't seem to be full screen for some reason just here in the preview, but we'll see if we can get to that. As usual, more technical problems than I care to imagine, just with a simple act of getting a webcam to work. So anyway, I'm going to assume you can see me in some fashion anyway. So what we have for you this evening is one part of a Tesla large drive unit inverter. This is basically what you would call a half bridge, and there would be three of these that form an inverter within the Tesla large drive unit. Now I've got a couple of reasons that I need to do a little bit of a teardown on this guy, so I thought, what the hell, let's do it live so that you can see me get the musk-goo all over myself. So based on that, we're just going to dive straight in here, and what we're going to hopefully discover is a couple of basic facts about number one, what transistors that are actually used here, because that is one piece of information that I just can't seem to reliably find. We're also going to be having a look here to see if it's going to be physically possible to remove and replace individual transistors within one of these half bridge modules, and just generally see what it is that we can learn. So, all right. First question, obviously, I just want to ask people if you can see here, and and so on. If I'm coming through clearly, etc. I hope I am. As I say, a bit of camera setup problems earlier today, so hope that's not affecting things too much. All right, so we're going to get straight in here. So this module here on the top, held in by the aluminium bracket, is the DC link capacitor, and on the end of it here is where the IGBT driver board is attached with three fasteners. Now fortunately it is connected with ribbon cable, so what we're going to do is we're going to pull out those three fasteners and see if we can fold the board down and see what we can see. There's some series of other, I think 8 fasteners holding the bracket on. We're going to see if we can pull those and see if we can pull this guy out of here and see see what we get. So okay, we'll pretty much get started on that then. All right. So there's little, I believe, Torx bits here. I think they're a T10. Yeah, they're a T10. So yeah, it's been a good while now since I've done a live stream, but it's just been kind of a lot going on. I didn't have any kind of a subject that kind of suited itself to it, but we've got some new Tesla stuff in the works for you guys. We're getting some Model 3 components now fairly soon, so hopefully this week even, depending on our wonderful customs decide to do. So this is also a chance to have a look at the back of the driver board here, which I've never actually done. I've never gone beyond just reverse engineering the basic signals that go into the driver board to get it to fire the IGBTs and create the fault signals for me. Now on the back here, I'm seeing straight away that there are 1, 2, 3, 4 8-pin ICs that aren't actually populated. Couple of passives as well in there that are not populated. Would be interesting to see. This is a standard non-performance drive unit, so it would be interesting to see if these are actually populated on the performance model, and may actually be involved with that one pin that I could never quite work out. There's one pin on the IGBT connector that on my own inverter never seemed to go anywhere, and I couldn't really work out what it was there for. So it would be interesting to see. At some point we'll get a performance inverter and see if there's any differences in that. So I'm going to see if we can pull out these fasteners for, yeah, great. I'm going to see if we can pull out these fasteners for the top bracket. As usual, I only pick the cheapest tools that money can buy. There, we just loosen them off anyway. And we should be able to rotate them out with the power driver. These are T15s. Great, we just dropped that into the goo. So just first general observation here of this is that we have 1, 2, 3, 4, 5, 6, 7, 8 transistors per side, but the bracket, there's a brackets holding the tabs onto the tops are actually broken in two. So there's 4 and 4, which I did find kind of odd. I would have expected that those tabs would have been connected together. So maybe that's just a mechanical reason, could be an electrical reason. Well, we'll see what we get, or not, depending on my screwdriver. Okay, so that's actually quite a long fastener. Oh yeah. Okay, let me get my tweezers at that one. Plus, haven't really seen anyone doing a teardown on one of these, so figure at the very least we'll all learn something together. Come by and all that. Seriously? Yeah, don't buy your tools in a supermarket, folks. Buy them at Harbour Freight. Well, good evening, everyone. It is a reasonably good evening for once, and I don't have to have the heating on, which is nice. Okay. All right. Whoa, seriously? Yeah, so the long fasteners are on the outside. Let me grab my tweezers here. We can get these ones out. So long fasteners outside, shorter ones on the inside. Again, I have zero idea whether it's going to even be remotely possible to take this thing apart without turning it into a pile of dirt. So, okay, so we got all those fasteners out of there. Now, I am assuming that we can perhaps lever. Oh yeah, okay. That bracket wants to move. Alright, that's interesting. Thought we might be fighting the musku there, but yeah, okay. So all 4 corners of this bracket, they want to come up. They're coming out of the goo. The bracket has releasing. Oh, we're up. We're up and out. Okay. So, first things first, our bracket is out of the musku. Yay. Now, so we are, okay, so interesting. Okay, so we have some information. This is a Panasonic SH film capacitor, DC 450 volts, 400 microfarads. Now, the question is, can we remove this capacitor? Now it's connected to the bus bars by these studs here. There's a series of 5 per side. So let me go ahead and see the back here. I think I did see some bolts around the back, but they may not be related to the capacitor. There's two very small little Allen bolt heads here. Let's see. What I'm going to do is, because naturally being as highly prepared as I am, I didn't bother bringing in the socket set. So I'm going to go ahead, get a little socket set and just loosen these studs here and see if we can move the capacitor. Now it's not critical for what I want to do tonight, but let's give it a try. So back in a few. Don't adjust that set. So you would easily know it's me because prior preparation prevents piss poor performance. Well, of course, piss poor performance is kind of what you come to expect from me. Now, what do we got? They look like 8s to me. Oh no, I'm wrong. 7s. Oh no, the goo got my socket. Yes, they are 7s. Okay. They're 7s. So let's crack them loose. Okay, cracking them loose. Yeah, no, Elon does make the goo. I have had that confirmed for me by, obviously unnamed Tesla sources. And considering that, there's a lot of cars getting churned out now, I really don't know how the guy does it either. But I guess, that's what makes him the Musk. Mere mortals such as ourselves cannot hope to achieve that kind of goo production. Alright, let's see what we got. Yeah, well, I'm never as happy as when I'm taking something apart. So, figure we need to take something Tesla apart. It's been ages. As I say, we got, actually I will have coming back to me for repair. Is actually a small drive unit inverter, so we will be tearing that apart too. So if you guys are more interested in small drive unit stuff, watch this space. Now, so I've slacked off the 5 studs, presumably holding the DC link cap in here. There's a little slot on the top, so I'm guessing we don't have to take the bolts off and that it should lift up, but who knows. Oh yeah, there's some movement there. The goo is flexing a little bit, so that's a good sign. Of course, I do have to have the wimpiest screwdriver possible to try to put a little bit of force on here. Oh yeah, okay. Maybe it's a good thing I have the wimpiest possible screwdriver. As otherwise I might make an absolute pig out of this thing and bust it. So I really don't want to bust it. Like, if I do have to bust it, we have to bust it. But consider this. Oh yeah, consider this. There we are. Consider this kind of to see how far we can get without, being able to reverse the process and put the darn thing back together again. Really. How much can we get away with? Can we make our own goo, for example? Oh yes, she's up and out. Okay, this is my first look into something like this. So here's our film cap. I interesting piece of kit. DC link goes on the sides, solid copper. I'd say it's about 2mm copper on there. And I don't know if this will come out on the video or not, because my video processing is oh, good. Okay, we got some decently good video then. SH film capacitor, DC 450 volts, 400 microfarads. Now, one question that I do get asked, because you know the nature of the open source board being that we're not tied into any of the Musk's limits, is what is the maximum voltage that we can put into this thing? Well, assuming, and we don't know yet until I take off one of these bus bars, if these are 600 volt IGBTs, which I'd assume they kind of nearly need to be, then we will be limited not by the IGBTs but by the voltage limit on the capacitor, which is 450 volts. But please don't everyone go running off and shoving 450 volts into your inverter, then getting on to me and say, Damien, my inverter blew up. Please don't do that. Now, okay, let's get you guys in here a bit closer. Let's get you in a bit closer. As usual, the bench is getting a bit filled up. Of course, my preview is going to be kind of garbage. What can we see now? Come on, there we go. All right, okay, so evidently our DC link here comes up to the caps here. It's a laminated bus bar. Looks like an insulating layer between the top and the bottom. The Musk goo didn't fully penetrate in here, so there's only, you know, kind of whatever coating is on the bus bar itself. The Musk goo, presumably, and it kind of makes sense, goes in as the last 3 frames per minute. What the hell? I'm supposed, well, this thing is supposed to be doing 30 frames per second here. So I guess that's not working. Great. Wonderful. Never easy. Jesus. Alright, give me a second. Seriously? I mean, what in the Sam Hill am I supposed to do with this heap of garbage? I suppose I can turn down the... Let's turn down the quality. That's gotta help. Oh, okay. Alright, let's see if we can crank it back down a bit. Maybe it works a bit smoother. Okay. Yeah, I'm guessing it's not 30 frames a second. Okay, I'm actually seeing the preview is a little better now. I've gone to non-HD, so hopefully this will be working a little bit better. Alright. Okay. So I guess either the internet connection can't quite handle the HD, or my computer can't encode HD, or whatever. But yeah, okay. All right, we're all set. Okay, so sorry we can't do a HD broadcast, guys. Thank the Irish broadband situation, or it's a flipping i7 laptop, but it is Windows, so I suppose that explains a lot. Maybe I'll drag out the Linux machine for the next. Okay, so assuming that everyone can now see and hear, next part of the plan is I'm going to go ahead, because part of this plastic is damaged here. There's a couple of little bits of damage on this unit, which is why I chose this for the teardown. So what I'm going to do is I'm going to get a Allen head screwdriver, which this one is too small, too small, too large. So professionalism at its height again. I'm now going to have to, do I need to get smaller Allen heads? Yes, I do. So bear with me, back after these messages from our sponsors. Wish I had sponsors. Yeah. Okay. no, I do usually only use Linux, but the problem I have is that I'm too lazy to learn how to use a Linux-based PCB CAD package, something like KiCad. So I end up stuck with Design Spark, and of course Design Spark only runs on Windows. So yeah, hence unfortunately I need to keep a copy of the darn thing going around. Okay, we found the right one. So we need a, what does that say? A H2.5? I don't know what that means. Anyway, enough about that. Alright, so each of these bars has 1, 2, 3, 4 bolts. One of them is free of the musk goo because, oh really? Okay, first one is moving. That's good. Okay, so I'm gonna bring you guys in closer pretty soon. Okay, so this is the first of these little cap head screws. I'm now going, oh god, it's stuck to me. No, it's really stuck to me. It's not coming off. Okay, I need another Flahavans Quick Oats tray here for these ones, because this is not going to end well. Get off! Get off, Elon! Get off me! Really? Okay. Let's in through the goo and into the next bolt. Oh no, these really want to try to ring off, so you have to lean into the oh no, the goo is changing. It's changing shape. It's, oh man, yeah. Okay, next one. I'm gonna just have to lean in again. There we go. Once you get them broken loose, they seem to move okay. But don't be tempted to not lean into them, because I guess it's the hydraulic action of the goo that wants to. Oh, this one will want to ring now because it's the last one. There we go. Wow, they're definitely torqued in anyway. Okay. God, this is like something out of a sci-fi film. Okay. Let's get that in there. No, really? Seriously? Okay, well, we'll stay on there then. Don't mind me. Don't mind us working stiffs. Another Flahavans Quick Oats tray. Flahavans Quick Oats trays are really handy for this. Alright, now let's see if we can remove. Can we remove this bar here? No? I'm not going to do it with that tweezers anyway. So I've got, yeah, pretty much all these guys are free. Not sure. Oh yeah, okay, the bar's moving. Bar's moving. Crap. Elon, damn your stickiness. Here we are. Up, up, up. Oh god, oh, I don't want to handle it. Oh no, I don't want to handle it. It's just going to be awful. Oh, Christ. Ah. Okay, I got it. I got it. I got it. It's out. Quickly. Oh no. Okay, so looks as if each one of these clamps is on 2 transistors. Let me move you in here a little bit. They're Allen heads. I don't know, 2.5 was on the bit, so I don't know what that means. Maybe 2.5 mil. Now I'm going to try and, oh yeah, okay. Here we go, guys. I'm going to try and remove this clamp. Release your secrets, Musk. Come on. Come on. I will know your ways. Okay. Success. Well, partial success. So now, okay, the good news is we've got one of these off here. I'm going to pull the second one while we're in here. Good God. This makes slime monsters from the planet X look like a children's film. Ah! It's out. Alright, so we're going to need something now to remove some of this goo. I did manage to bring a trusty knife with me. Alright, let's get a knife. Because I do want to see, now unless of course Elon has been his usual self and he's removed the info on the transistors. Oh no, he hasn't. I can actually see it. So the good news is we've got transistor info. Okay, the bad news is my hay fever is kicking off, so if I start sneezing violently, please don't everyone, you know, assume that I don't know, that I've been taken over by the goo or something, because, oh man, this is just awful. I mean, okay, I know why he's got to secrete this stuff in here, but Jesus. I just gotta see, Elon, I just gotta learn your secrets. Just one more time. Oh, but there'll be more times though, I suppose that's not quite fair. Alright, I got some numbers on here, so you're gonna see my big head in the way now in a second. I'm gonna have to get in there with the old magnifier. Oh, really? Alright, I got some numbers, but not very clear. So let me get, oh no, the goo has reclaimed the secrets. I'm gonna have to get something to wipe some of the goo out of there. It keeps trying to reclaim the secrets. Secrets of the Musk. Episode. Let's see if I can use the bit of this paper towel. Here. Oh no, it's got the paper towel. Let go, Elon. Curse your superior intellect. What film was that from? I laugh at your superior intellect. Oh, Star Trek 2. Yeah, Kirk said it, didn't he? Khan, I'm laughing at the superior intellect. That's enough to get old Khan fired up. Oh, here we go. Here we go. This is working. This is working. Okay, I've got some numbers. I have got K75T60A. So, okay. K75T60A. There's goo down here. I'll try and get that away from... Don't think there's anything else of interest. I'm going to ask friend Google about that now in a minute or two. Let's see what we find. Because another question, of course, that I keep getting asked is, Damien, how much amps can the Tesla inverter take? To which I say, I don't know. But I heard it can do this, I heard it can do that. Yeah, me too. Doesn't mean I know. So, K75T60A. Oh God, I hope I don't turn into an Elon clone. Okay, let me go. K75T60A. Yes, I'm tapping into the computer. Okay, we got him. Let me see if I can get you guys a screen capture type thing going on here. This is interesting. This is very interesting. Okay, let me get you guys a screen capture type thing going on here. Geez, anyone would swear I knew what I was doing. Well, not. Yay, here we go. Okay. All right. Yeah, that's all good. Okay. Can everyone see? Hopefully everyone can see the screen capture. So this is the transistor that Tesla used in the large drive unit inverter. Let me nip over to you guys here. Okay, yeah, okay, everyone can see that. Okay. So, low loss duo pack. Very low VC sat. That's good news. Maximum junction temperature, 175 degrees. You wouldn't want to get near that. Positive temp coefficient in VC sat, so they'll share current. That is good. Tight parameter distribution. Okay, we like that. Very high switching speed. This is going to be interesting, because we're currently running 8.8 kilohertz into the large drive unit inverter. Of course, we don't know what the switching frequency is that Tesla themselves use, but this is an interesting little parameter here. So, all right. Okay. Everyone's seeing this? Please tell me everyone's seeing this crap. I'll put a link in the description when I post this up anyway, but this is the transistor, folks. So what's the first interesting thing is that it has a rated collector current of 75 amps. Now, you got to watch. Oh, okay, that just took the wind out of my sails, because I was about to say that when you read power device data sheets, you've got to be very careful, because usually they spec the collector current at a case temperature of 25 degrees. In this case, they have actually specified it at 100 degrees, which is much more realistic. That is interesting. We've got a good bit to learn from this data sheet. I'm not going to take up the full live stream with me going through the data sheet, but let's get a few of the biggies. It is a 600 volt part. We kind of guessed that, but it's nice to know. Oh yeah, so marking is K75T60, so we're got the right part. Pulse collector current, don't really worry about that. Short circuit withstand, 5 micro. Nothing really there we want to know about. I want to look at the dynamic characteristics here now. Does have a diode in there. Here we go, dynamic characteristics. We have got a input capacitance 4620, gate charge of 470 nanocoulombs. Okay, that's more for switching speed that we need to worry about, so not a biggie. Okay, allowed number of short circuits less than 1,000, and the time between shorts has to be less than a second, but it can handle 690 amps on a short circuit. Let's see, turn on delay 33 nano. That is extremely fast for an IGBT. Turn off, of course, is, you know, traditional IGBT is, they take a lot longer to turn off than they do to turn on. Now, switching characteristics. Turn on delay 32. Turn on energy. Okay, so here's switching. Here we got ourselves a switching frequency graph, which is interesting. So taking it at TC 110. Collector current is a function of switching frequency, so what we can put through it versus how fast we can actually drive it. This says that down here at our, I hate these damn diagrams, 10, 9, 8, so I'll call it 9. That means that at, where's TC 110 is this one. Let's say 9 kilohertz, we're up around here somewhere, which is, wow, that's like 200 amps. Now again, the characteristics here are not going to be the way Tesla drives them, so we got to watch out for that. Anyway, did promise I wouldn't read the entire goddamn datasheet for you. During this video, we've got more teardown to do. So, for those of you that want to know, this is the transistor that Tesla use in the large drive unit. Now, a little bit of fun is, can we actually buy them? Can we actually buy them? So, Mauser. Say the only chance of anyone having them would be Mauser. Unless Elon's bought them all out. Has he? They are in stock, folks. They are in stock. This is the one. We got them in stock. And this product ships free. Yay. They have 258 in stock and they will cost you €7.23 each. So that's good news. Now, this begs the question, are they removable and replaceable? So let's get back to the Muscu and find out. Going to get rid of that. Yes, I wish to remove that, and we're back hopefully here. So, all right. Okay, excellent. So, that is a bit of data for us, folks. Our 75 amp transistors at 100 degrees C case temp. So, let's have a, oh God. 1, 2, 3, 4, 5, 6, 7, 8. Can someone multiply 75 by 8? Here, hang on, I'll do it. Thankfully, we have calculators. $600 amps. That's very, very interesting. So, if we go by the data sheet, this is a 600 amp inverter. Now, that bold plot. Okay, I said I wouldn't do it. Sorry. No, I'm not going to do it. I'm not going to do it. Okay, I am not going to start doing all kinds of weird electronic engineering stuff tonight. What I am going to do next is I'm going to remove this guy here. Now, well, hang on. So, what we've got that I can see is our transistor legs here are attached. I'm not going to say soldered because they're probably welded. They're attached to the bus bars here. There's 3 legs for each transistor, so let's start with this one. Assume it's these 3 legs here. One is soldered to the PCB, which is our gate driver board. Now, interestingly, each transistor has got a 20 ohm resistor attached to its gate and what looks to be a 20 ohm resistor pulling down its gate. Now the question remains, oh yeah, okay, because these are, I was always assuming that Tesla used a tab to connect back to the DC link, but they don't. They use the leg. They use the leg to connect back to the DC link. And of course there would be 3 layers to this DC link, because there has to be a positive and a negative for the battery, but then there has to be a connection between what would be the emitter on the high side and the collector of the low side. So they're literally connecting them across the way. At least that's what I'm assuming. I could be wrong about that, because that would be quite a torturous path. Now interestingly, on the PCB it says high side, low side, and over here it says low side, high side. You've been clever, Elon. Okay, so I've got a leg here attached to one of these. I'm going to have to remove this guy. Let me just try and just lever a transistor here for a minute. Oh yeah, okay, they're all moving. Oh yeah, they're going to move. They're going to move. They want to move. They're little party animals. They like to move it, move it. Okay, now, so these clamps, God, pretty, God, zooks, yeah. So these clamps are pretty much all that's holding the transistor in, okay? So once you remove the clamp, you're taking the physical connection away. Now I know that's dangerous, assuming things. Let me try something here, guys. Let me try something. I could be way off piste with this. I think I have some syringes here somewhere. Here we go. And don't worry though, I'm not taking up intravenous drug use. At least not yet. Let me get some water here. Thirsty stuff. All right, we're back in business. I wonder how fluid that this goo is. I mean, can we actually suck it out? And the answer to that question is no. At least not through that syringy nozzle thing. Nope. Musk goo is quite resistant to suck. Next lesson. Okay, I'm seeing a screw thread coming in on the back here, and if we flip over, oh yeah, there we go. This heads come in here, and I'm assuming, again dangerous, this is where our cooling channels come together. So, oh God, more of these damn things. So the question is, if we actually did want to replace a set of transistors in here, I think what we would need to do, we need to examine these connections. We need to pick one and examine it. Now what you can pretty much see here, well, let's see, okay, that's one transistor leg. I can kind of probe with the screwdriver a little bit. This is definitely one leg of the transistor. This is one, and this is one. Okay, let me get you guys close up on this thing, okay? So I want to try and show you how this operates here. Crap. More camera skills or lack thereof. Alright. Yeah, let's go for extreme close-up stuff here now. Alright, here we go. We're coming into land. Oh yeah, oh this is going to be good. There we are now. Alright. Okay. How are we looking? We're good. Yeah, try not to watch too many videos now. So, looks like, okay, what we've got here, is this thing focusing or is it just playing with me? I think it's playing with me. Alright, let me move some of the quick oats out of the way here. Bring you guys in for a bit of a, oh yeah, you're going to get to see my pleasant looking visage. There we go. That's better. Okay, that's better. Okay. Alright, that is better. You can see something now. Alright. What I've got is I've got 3 connections here. This is Q32. So we can see that the legs of Q32 are basically welded to our bus bar. And the gate pin, which I'm assuming is this one, is just soldered into the PCB. Now, this leads us to the conclusion that, interesting, E17, that says, E17, Q32, E16, Q31. This leads us to the conclusion that if we were to need to remove it, we would need to remove this PCB from one side. We would then need to, now assuming that's ordinary solder, so let's find that out. Turn on the soldering iron. Oh God, okay, let's turn on the soldering iron. Got my trusty blade. Come on, Elon. Come on, stop it, Elon. Oh, man. And speaking of clones of Mr. Musk, this does look a lot like that goo that the clones usually come out of the cloning tanks all covered in, doesn't it? Or have I just watched too many cheap sci-fi films? Probably a bit of both. Alright. Now, interestingly, if one, now let's see how that solder joint reacts to a little friendly solder removal therapy, shall we? Which, yeah, 75 amp transistors, huh? The old Musk, I know. Oh wait, hey, hang on. Oh God. Oh, it's got me. I know, no, I know. The goo is actually peeling away quite nicely from this board. Once it's got an affinity for human skin, okay? So do keep that in mind. It wants to be in contact with the human body, which leads me more to think this is how Elon does it, guys. This is the crap from the cloning tanks that he would normally have been flushing down the toilet. But he's found a way to reuse it. This is why it's got such an affinity for my skin. It's probably mapping my DNA now, which will take it all of about 3 minutes. So I haven't really evolved that much. Jesus. Right. Okay, I've got a solder joint here, which would be the gate of Q32. Let's see how it reacts to some solder removal therapy. First lesson of solder removal therapy, add more solder. No, I'm not joking. Okay, good news, it's just ordinary solder. Now let's heat the shit out of it. Oh yeah, that worked. Damn. That actually worked, guys. Now, I've still not got all the solder out of the tube, but yeah, it pretty much... I think removing one of these PCBs is probably not actually going to be that hard. Let me add a bit more magical mystery solder in here, and we'll go for a second extraction on there. For those of you that maybe don't know, the reason we add solder when we want to remove solder is that modern solders are all lead free. We want to add some lead to let it flow easier. So as opposed to get the lead out, we want to get the lead in. Now what I should get myself, of course, whoa, hang on, someone's figured out what the goo is. It's a polymorphic metamorphic pentambion alloy is going to kill you after chasing me down the street. Christ, I hope not. I can't run that fast. So, alright. That's more Terminator though, isn't it? Like Terminator 2 stuff. Hey, anyone seen the trailer for that new Terminator film? It does look kind of weird. So, alright. Looks like standard solder joints here for the gates. So the procedure would be, because they've got clearance holes around the PCB, what we would need to do would be to unsolder the 8 gate pins and then gently lever out the PCB. In fact, let me do something a little bit crazy again here. Obviously, I'm not going to go through this whole procedure here on a live stream because number one, you'll be asleep, and number two, I will as well. But what we are going to do is hopefully identify a procedure that will work for us. So shove more solder in there. Come on, Elon, suck that solder in, son. Suck it in. Now, if I take my blade, oh yeah, that PCB starts moving. Look. No bother to it. Okay, so what we would need to do, got you covered. Oh, pro tip, the only solder braid that actually works is this tech spray stuff, and you've got to get that from the United States. Tried finding it here, no go. They sell you instead, what they sell you is this garbage that looks like it, even feels like it, but trust me, when you've ripped the pins off a 256 pin QFP, you will find that it is actually not tech spray. Don't use this. Alright, so looks like this would be, as jobs go, fairly straightforward task to desolder the 8 gate terminals and just move this PCB up, and then you would be basically left with your transistor with its gate and emitter pins welded to the DC bus bar. So this is pretty much how the large drive unit inverter goes together. So replacing transistors in one of these should be eminently feasible. Now, until I actually get this off and we go in and we see how these are affixed, you know, okay, that is going to be something, how that copper welding, you know, it's most likely laser welded or something like that. So we'll need to investigate that. Now, interestingly, okay, there's some other connections going on in here, but as I say, until we pull the PCB, we're not really going to know that. So this is about as far, yeah, I know I'm not, I don't think I'm going to bust up a perfectly good inverter power stage yet, because number one, I have a little bit of a plan. Now I do have 2 of these, so it's not too much of a problem, but obviously if I don't have to destroy something, I'm not going to do it. Primary thing was today to find out what the transistor was, and also the cap, which we managed to find out about, and to see, yeah, if it's even remotely feasible to replace them, and I think it is. I mean, you got €7. Where was that Mauser page gone there? Where am I gone? I mean, if you buy 10, you're at €6.53, so 65.30 for 10. So if you were to buy 16, and let me just bang this in here for the fun of it, what would 16 of these set us back? They would cost us €105 to replace all the transistors basically in one of these. So that is in no way what I had imagined that it was. I thought this was, you know, mega bucks, you know, $1,000 worth of transistors or something, but yeah, not the case. Yeah, very interesting, very interesting stuff, folks. Hope you have at least partially enjoyed some of this garbage tonight. Yeah, K7568. I could have sworn these would have been like 240 amp parts or something like that. So now one other little thing going on here I've just spotted. There's a little manufacturer's sticker on the just down here, this little white sticker. Let me see if I can get you some details on that guy. Okay, it says Rogers division, something division. Some part numbers on there. Could be to do with who makes the bus bars for them. Yeah, but I think that's about us, guys. I think we're as I said, what I am going to do next, obviously, I'm not going to do it now. It'll take me, a certain period of time to pop this little board off here, so we can get in and get a better look at what these, how these connections are made. Because, oh God, because it's not immediately obvious. The goo is filling everything. Now the goo, by the way, another question I get asked is about replacing the goo. This is what's called a re-enterable potting compound, because we're entering it. God, yeah. So you can buy these, these are available. Obviously you probably won't get the same one, but unless we maybe get Elon on Twitter to tell us what the goo is. But he's only really does memes on Twitter anyway. Ow! Yeah, I'm just trying to. So you're going to have to see my big head in here for a minute. It's hard to say, guys. I mean, it nearly looks soldered, but I'm pretty sure it's not. It has the look of a solder joint. Pretty sure it's not. I wouldn't have. I mean, I don't know. What do you think? Could they be soldered? I very much doubt it. Plus, I very much doubt it. I very much doubt that these are soldered. Plus, I also doubt that my soldering iron would even put remotely enough heat into this to be able to desolder it if in fact it were. But I'll just play with it here for a sec. Let me just see what happens here. These have to be welded. There's no way they're soldered. We're definitely rocking the thing there back and forth. I would be beyond shocked if they turned out to be soldered. Yeah, plus I don't think as I say, even if they were soldered, I don't really think this little, SMD soldering station is going to put enough heat into it. I need to break out the big 100 watt to try that. But anyhow, that's not bad, guys. Other thing, just that does come on one of the inverter phases for you, just for people that might be interested and might have seen it and are wondering what this guy is. It's this little PCB on the back here, which we are going to take a little bit of a closer look at. This is the DC bus discharging controller, for want of a better word. So this basically short circuits the DC bus with, obviously a resistance for the purposes of discharging the capacitors when you shut the drive unit down, just in case anyone was wondering what that little guy does. And on the back here, now let me flip this up for you guys. So this is the back of the IGBT driver board. I know it's going to be upside down for you, so sorry about that. Here on the back, we've got, what have we got? We got 2 resistors that aren't populated, and I got 4 8-pin devices that aren't populated. Couple of passives going around here. I'm going to take a pretty big guess that these devices are somehow connected to that mystery pin that I've never been able to figure out what it does. So we'll be very interested if anyone has a performance drive unit inverter with the red PCB, maybe to get a picture of the back of one of these, because from what I could see on the top of it, there was absolutely no difference. So yeah, all right. But basically, yeah, getting in here is not as nightmarish as I would have thought. These transistors are not as expensive. They're certainly not the transistors I would have thought they were. A 600 amp inverter. I mean, that's kind of super weird because, yeah, we all had assumed that, well, at least I had, that Tesla were using these TO247 packaged parts to get the power. I mean, you know, we're probably not the best example, but you know, there's a 450 amp 1200 volt brick. I mean, you can easily get 600 amp 600 volt bricks, and it's, you know, it's kind of that. So it's what the hell, Elon? Want to explain that one to me and stay fashionable, as they say. Anyway, that's what we got, guys. That's what we got. Do want to have a good look at switching frequency, as I say, because switching frequency is something, as I say, we run 8.8 into these. That seems fine, but there might be something to be had if we can take that frequency a little bit higher. So, all right, I am not going to, well, yeah, I mean, obviously there's huge, you know, pricing things in there. You certainly wouldn't get one of these brand new for $100. So yeah, alrighty, I will. If anyone has some questions you want to shoot at me, I will give it 10 minutes for questions. And other than that, you'll just hear my musings here. And I'm going to wrap things up for this evening because I've got a date with a cup of tea and a ginger biscuit coming up. By the way, just on the subject of Tesla, we are going to have very soon, I said, some Model 3 stuff, and I know that one part that's on the way to me, it's actually in the country, but our friendly customs are doing their thing on it at the minute, is a Model 3 power conversion system, which is a kind of amalgam of a charger and a DC-DC converter. So we'll have that on the bench soon. Oh, look at this. See this? See? Look at it's the cloning goo. Keeps trying to get me with the cloning goo. All right. Oh, Tom, you've given it away. Come on. Ah, yes. Okay. Okay. All right. Plan is to make a super high power DC motor controller out of one of these Tesla inverter phases. Tom's just given the game away. So yeah, basically to do that, all as I've got to do is get a little plate machined to go on to the liquid cooling slot, so we can just put normal hose connections on there. And then with a very simple little control board, you've got yourself a mega power DC motor controller. And one of the other things, actually I will draw this for you, because one of the other things that you could do, let me see here, and I had done some experiments with it literally ages ago. Where am I gone? My highly organized live streaming plans. So one thing that you can do if you have, you know, half of an inverter is you can, okay, so the first thing you do is you take, obviously, you know, so your inverter is going to look, I'll flip this around the right way, it's just I can't draw transistors the wrong way around for the life of me. So yeah, okay, so IGBTs, so let's say that we had, you know, B1 plus, B2 plus, and we have B1, B2 negative. Now, okay, let me flip this around for you. So, if we took our two inverter halves that we've got, and we had a battery voltage here, we had a battery voltage here. Now we connect the grounds to a common rail, but we leave the B pluses separate. And we go in here in between on our phase connection. We do this. Obviously, I'm not drawing the body diodes, but just assume the body diodes are in there. Well, anyone want to take a guess? Oh, yes. Anyone want to take a guess that what we could do with this? I'll give you 10 seconds. Oh, damn it, Tom, you keep spoiling the fun. Yes, you can basically make yourself, you can convert from here to here, or you convert from here to here, and it can be a higher or a lower on either side. So you could buck up, you could buck down, you could boost up, and you could boost down, just by how you would switch the transistors. Now, traditionally your problem would be the magnetics here. How do you, to get a ferrite core to handle, several hundred amps that you would want to put through the thing. But if I'm remembering this stuff right, in a switching converter like this, the current within the coil never changes direction. It's always flowing in the same way, so it's not going back and forth. So you charge the inductance, let's say, with a current coming in this way, so the magnetic field builds up. You then switch off, and obviously then the collapsing magnetic field in here wants to continue to keep the current flowing. So as the magnetic field shrinks in, it's going to try to keep the current flowing. So because you're not using the core material, in both directions, you can use a laminated core. So that basically, lets you just take any kind of an old transformer core and just wind the hell out of it. Anyway, that's a little bit of another crazy project. But yes, DC motor controller out of a Tesla inverter is definitely on the cards for us. Alrighty, so yeah, obviously one of the things that lets you do is build a demo charger for quite small, actually. 100 amps, 125 amps for a demo would be quite easy. You could even get up to, bigger currents than that. So, anyone else want to shoot any quick questions to me? Otherwise, I think I have probably exposed people to more than enough muscu for one night. I know I've definitely exposed myself. Oh no, there's sneezing happening. Hope that's not a side effect. So I will be back soon, guys, with some regularly scheduled video for you. We have a lot of projects on the way. Hopefully going to have you some video on a new project this week, and much to my how should I say, annoyance, not really annoyance, but dismay, it's not a BMW. So yeah, we will keep you posted on that. What's next for the Panzer? Well, the Panzer is, what is the Panzer doing? The Panzer is currently getting fitted out with Tom's BMS, and that is working away very nicely. We've been going back and forth, tweaking the software a bit on that. Oh yes, I've got to do the paint protection on it. Yes, I've got to do the paint protection on the car. So that's some G-Technique stuff that I need to get done as well. But that's about it at the minute. I mean, I'm just having so much fun driving the thing that here you can look at me instead of looking at the damn thing there. Yeah, I'm having so much fun driving the car right now that yeah, it's just I take it to Tesco for Christ's sakes, you know. It's just a barrel of fun. I didn't get supercharging can capture. That is something that I'm looking for. If people do have or have any info on that, that would be much appreciated. Do have a new charger board coming out soon. In fact, the PCBs should be here this week for it. That has some additional features on there that hopefully will support a few other things like Tesla destination charging and supercharging. One thing that I am not going to talk about tonight is the kind of training course stuff that we're hoping to set up, and the reason for that is that I will have a dedicated video for you guys. I'm meant to have it this week, it just didn't happen for me. There was so much going on. It took me a week to get some simple parts for the red arrow just for our NCT repairs, so that was a nightmare. We'll have a video on that, and that's going to be fun, where hopefully, if all the stars fall into place, yeah, I'm going to be able to show you guys how to build an EV from start to finish, so stay tuned. Yeah, front wheel drive stuff. It's funny to mention that. I had I was talking to, no, I wasn't talking to, I saw it on the Open Inverter forum. There's a guy using one of the Lexus RX 400 diffs. Hoping to get one of those fairly soon to have a play with. Biggest problem they have is cooling, but you know, you can do that with a simple oil cooler. But in terms of a front wheel drive car at the minute, I have still literally looking at my Prius drive unit stuff here, or drive unit, Jesus. Gearbox, Prius gearbox. That will hopefully be a good choice if I can ever freaking get the time to finish testing out the controller on it. Then we got to put that in a car. Christ, too old for this crap. I need to just have a, ideally I need to have like a whole big factory kind of workshop-y type thing full of people that just do my bidding. That would be cool, you know. Put this motor in that car, or run 100 amps into that component, or you know, discharge that battery, or do all this kind of thing. I'd be like some demented Elon. All right, guys, I am definitely going off the rails a little bit, so I will park it there for tonight. I'd like to thank everyone for tuning in. Do apologize that it's been so long since we have had a live stream. Hopefully we'll have more soon. Things like this where I can do a defined kind of a learning experience type of thing, I think are good. As I say, I've got a small drive unit inverter on the way into me, so we'll do something similar to this when that guy arrives. And we have the Tesla Model 3 stuff coming in. I'll do some of that live, but I'll do a lot of it in video too for you. Just so it's, you know, it's, the live streams I tend to ramble. They're a bit more spread apart. Whereas if you want to, you know, you can condense it. Probably condense this down to a 10-minute video, which people can do by fast forwarding. So that's me attempting to speed things up for you. All right. leave it there, guys, and we will catch you on the flip side, or as the guy in that Denzel Washington film said, my work here is done. It's on the shades. See you on the dark side of the moon. I just think a damn thing will turn off now. I'll be doing well. Ugh.